Hello and try that again. Hello and good day, Algebra. We are back with PO55, covering the last of the types of the equations that you'll need to find x-intercepts of. We've already talked about ax squared plus c, and really this entire section here, they're all key points. Please put this on a help sheet. It's a great cheat sheet for what to do. When you have an equation in y equals ax squared plus c form, your method is order of operations. You're solving this like any other equation, and your solutions will be opposites. You know that. You'll have two of them, and they'll be opposites. When you run into an equation in y equals ax squared plus bx form, your method, factor of that greatest common factor, you know you'll get two solutions, one of which will always be 0. The one we have not talked about yet, but you've done before, is ax squared plus bx plus c. This has got everything. It's got your x squared term, it's got your x term, and it's got your constant. Where have you seen an equation like that before, and what did you do with it? Think back to last unit, particularly POs 51 and 52. Or just read what the method is to solve this and just repeat it to me. Factoring. You factored before, right? PO51, PO52, you factored. You're looking for, remember, those two sets of parentheses, right? One will have, both will have an x in it, that whole situation. That's your method for solving these. Okay, so this one, even though it looks to be maybe the most complicated, is the one you're most familiar with. So ax squared plus bx plus c, here's our equation. Again, remember, we're turning that y to be a 0, because to find an x-intercept, you need that y value to be 0. And what do we do to factor this? Who remembers? Connor?
The UCF.
Not the greatest common factor. That's for ax squared plus bx, so there's no c term. This one's got all three of them. It's got that constant. To review for this, go back to PO51, but we're looking for two numbers that multiply to equal the constants. Remember this? And what's the second thing? They multiply to equal the constant and add to equal your middle term. Okay? Two numbers that multiply to equal the constants and add to equal the middle term. That's what factoring is. We did it back in PO51. And what combination of numbers work here? 4 and 5. Okay? Does it matter which order you put them in? 4 and 5 versus 5 and 4? No. Okay? No. So our solution now, if you remember, we've got two sets of parentheses. Each one starts with an x. That's how we get that x squared term there. And we FOIL Kraft-Law box, right? One of them gets a 4, a positive 4. And the other one gets a positive 5. Okay? Now in PO51, you stopped here. This is it. This is all you needed to do for that. Okay? Now that we're solving for the x-intercepts, we have to go one step further, because we have to now say, okay, what value for x makes this equation equal 0? Because that's going to be the x-intercept of the parabola. And just like yesterday, we have two expressions here that we're multiplying together. So we're going to take them each separately. What value for x makes x plus 4 equal to 0? What value for x makes x plus 4 equal to 0? Negative 4. If you remember, as long as we make this first set of parentheses equal to 0, it doesn't matter what the second set is, because 0 times anything will still give us 0. Right? And then in the second set, what value for x makes x plus 5 equal to 0? Connor? Negative 5. And again, as long as we make that second set equal to 0, it does not matter what the first set is, because 0 times anything will give us 0. Okay? So negative 4 and negative 5 are the x-intercepts of this parabola. Right? Questions on any of that? Again, if you need to review the process of factoring, PO51 is where we've done it before. The only extra step now is looking at our sets of parentheses and saying, how do we make each one equal 0? Because that will be the x-intercept of the parabola. Are we going to move on to the next one? And I'll scroll up so that you can see a little better. We're good? Okay, all right. Next one, y equals x squared minus 3x minus 40. We again know this is going to be a factoring equation because it has all three terms, x squared, x, and a constant. So we can go straight to our equation where y equals 0. And we're looking for two numbers that multiply to make negative 40, that constant. And those same two numbers add to make negative 3, our middle term. What's the magic combination here? Sarah? 5 and 8. And since we've got a negative 40 here, one of them's got to be negative. Which one, 5 and 8, will have to be negative to get that negative 3 when you add those numbers together? Tomorrow? Negative 8. Right? Negative 8 times positive 5 is negative 40. Negative 8 plus 5 is negative 3. So, in our parentheses now, again, we have two sets. Each one gets an x. In one set, we've got a negative 8. The other set, we have a positive 5. In PO51, that's where you stop because your only job was to factor it. Now we want to go one step further and solve the equation for x. What values for x make this equation equal 0? So we look at each expression individually. What value for x makes x minus 8 equal to 0? Someone new? Yvonne?
Positive 8.
There you go, positive 8. And what value for x makes x plus 5 equal to 0?
Negative 5.
Negative 5. Okay? And here's why those POs are so important. You know, if you never really quite got PO 51, then not only are you kind of doing the new part here, which isn't so bad, but you're also having to relearn PO 51. But if you already have that down, then you're probably, oh, this is pretty easy. That's why the POs are out there. Okay? Questions on this one? Okay. The third one is a little bit different. What's different about that third one compared to the other two? Connor? It's got that coefficient to x squared, which means what? How many steps are in this process? No, not quite 8. Okay, 7 steps if you check your answer, but 6 steps otherwise. This is the one where we have to factor out the greatest common factor first, then multiply A and C together. Remember this one? PO52. Okay, so for this one where you have that coefficient to x squared, you want to go back and look at PO52. But we'll run through all the steps again here. So our first step is factor out that greatest common factor. Do we have one between 6, 11, and 10? No. So actually, get kind of a break. We don't have to do step 1. And we also won't have to do step 6 when we're all finished. All right? So step 2 is multiply A and C together. Right? In this case, that's 6 times negative 10, which is negative 60. Multiply A and C together, 6 times negative 10, which is negative 60. Now we use that negative 60 right away in step 3, where we're looking for two numbers that multiply to make negative 60 and add or subtract to make 11. Okay, because this has a coefficient to our x squared term, this multiplication can't just equal the constant. It's got to be the product of the constant and the coefficient to x squared, the A and C. What combination of numbers makes this happen? We know one's got to be negative because we got that negative product there. Lauren? Good. 15 and negative 4. 15 times negative 4 is negative 60. 15 plus negative 4 is positive 11. Okay? Now in step 4, where we start to put it together, we've still got two sets of parentheses here. Right? And remember, both sets get what? Both sets get the same thing. Annika?
6.
Good. They both get a 6x, right? That a term from the equation, they both get a 6x. And the reason why we do that is because now it doesn't matter which set of parentheses gets the 15 and which one gets the negative 4. Because we start both of them the same, it doesn't matter which one gets which constant. We're just kind of bending the rules a little bit, which is why we make up for it in step 5. What is step 5 here? How do we fix that little mathematical shortcut that we took?
Simplify the 6x plus 15.
Simplify any set, either set, whatever you're able to do. And we simplify by dividing by the greatest common factor of our two numbers, 6 and 15. That now gives us 2x plus 5. In our second set, we can divide by 2. Since 2 goes into both 6 and 4. And that gives us 3x minus 2. And how do we know that we've done this correctly? What's the little hint that this gives you that you say, okay, this is right?
Plug your answers back into the equation.
Well, we're not done yet. We're not quite done with the answer. You could foil crab claw box this to see if you got the original equation. So you are right there. I mean, you could foil crab claw boxes. But what was the other thing? What was the other thing with these numbers here that we talked about was significant? That those aren't the numbers just by accident. Anyone remember? Morgan? Annika?
If you multiply 3 and 2, then it's equals 6.
Exactly. Because we put that extra 6x in, what we simplified by, if you multiply those two together, 3 times 2, you get that 6. So you put an extra 6 in. By simplifying, we took that 6 back out again. Okay? And then you can ultimately check this, because this would have been a final answer in PO52. You can ultimately check this by foiling, crab clawing, boxing, make sure you get the original expression. But we're in PO55, so we're not done yet. Okay? We're not done yet. We now have to solve this for x, because remember, this equals 0, right? So we're going to take each expression separately, just like we did in the first two examples, and figure out what value for x makes that equal 0. Who can tell me? Noah? Sure. Connor?
Negative 2.5.
Negative. How'd you get that?
2.8 for x.
Did you do a guess and check method type deal? Or?
Yeah.
Okay. So guess and check method is fun. Sometimes it's easier than others. But what do you recognize? Think back to yesterday, that shortcut that we talked about. Isn't this expression in ax plus b form? And what was our little formula or shortcut when you have an expression that you want to solve to be 0 that's in that form? Yeah.
You use the two numbers in the parentheses.
How?
5 becomes the numerator, 2 becomes the denominator.
Okay, and there was one other piece to that too.
If it's positive, it becomes negative.
Right. It's the opposite of b divided by a. The opposite of your constant divided by the coefficient. Right? So our constant is 5 here. The opposite of that would be negative 5 divided by your coefficient 2. Now, Connor said negative 2.5. If you were to divide that in a calculator, that's exactly what you get. Now, why that works, where that comes from, like we said yesterday, is if you're solving that expression to be 0, just standard solving for x, what would you do first? Well, you'd subtract 5. That's where your negative 5 comes from, right? The opposite of your constant, because when you move it over, the sign changes. Then what would you do? Well, you divide by your coefficient. Divide by 2. and you ultimately get x equals -5 over 2. Okay? So it's the opposite operations that's solving that equation for x that gets you there, but there is this little formula shortcut. So what would our other answer be? What's our other x-intercept here?
What does it equal?
Yes, what value for x makes that expression equal to 0? It is 2/3, positive 2 over 3, right? The opposite of your constant divided by the coefficient. Okay? So there you have it. You now know all 3 methods for solving all 3 types of a quadratic equation. Okay? Your homework today will only focus on this 3rd type, only the factoring. We kind of covered the other 2 previously. This is it. So go ahead and scroll or flip past the next page to here, starting with x squared plus 11x plus 18 equals 0. These 6 are all set up to be ax squared plus bx plus c. You see that some are written a little bit strangely. We're going to sort them all out before I said run the homework. This one's standard. Nothing to work with there. That is in ax squared plus bx plus c form. This one with those parentheses, I want to help you out a little bit. Your first step would be to distribute that x term into the parentheses, which gives you x squared minus 13x equals 30. Oop, we'll hold that thought. Yellow. Yes. Okay. Okay. Bye. She was whispering, so I want to whisper too. Connor, you have to go start your science test. Yeah. By the way, wasn't that a fun surprise?
No.
Today, take that science test.
So fun.
Did you find it
It was
easy?
great.
Hard?
We all failed.
Well, you clicked the
I
answer.
didn't get
Right.
my rest side this time.
Nobody knew.
Really?
I hate
Because he didn't like just 80 days. Yeah, if we get above 75, the next, our last test. It's probably gonna be on the last day of school, like last year.
Like, so it's always optional? Okay, we're gonna start do it again. So 3, 2, 1, fight. Okay, so now we are here. We've taken care of the parentheses, distributed that x in. This gave us our x squared term and our bx term. Our constant term is there. It's just what? On the wrong side of the equal sign. So your last step to get this into a factorable state would be to subtract 30 from both sides, right? It goes on the left side. The sign changes. Yes. The sign changes because you're moving it from one side to the other. It's a tricky door. So x squared minus 13x minus 30 equals 0 is what you are factoring. Everybody right now, write this down. If you don't want to show the intermediate steps, fine. But write that ultimate form of the equation that you are going to be factoring. Okay? How do we take the next one? How do we put that one into standard form? -5x was x squared minus 66. What would we do? Put that in a standard form, a factorable state of affairs. Yes?
5x.
You'd move the -5x over, and because you're moving it from one side to the other, the sign's got to change. Make sure that you're putting it in the right spot, right? Since it's your x term, it's got to go in between the x squared and the constant. So your equation that you're factoring is 0 equals x squared plus 5x minus 66. Okay? 0 equals x squared plus 5x minus 66. The bottom, similar to the second one that we did there, we're going to have to distribute that 4x into parentheses first. So that's going to give us 4x squared plus 16x. And then our constant of 15 equals 0. We don't have to do anything more. That is in standard form. The next one, this 20 is a bit of a problem. It's on the wrong side. We have to move it over to the left side. And again, because we're moving it, the sign has to change. So 30x squared plus 25x minus 20 equals 0. And then that last one, again, that x term is in the wrong spot. We have to make sure that we move it correctly in between our x squared and constant term. Because we're moving it, the sign changes. And so your factorable equation is going to be 56x squared minus 22x plus 2 equals 0. Okay? So there you go. Those are your 6. If you start with these 6 equations written in green, they're all set up for you to factor. It doesn't matter if the 0 is on the left side or the right side. It makes no difference at all. You're focused on what the expression is. We've got about 3 minutes left. Is there anyone that you want to start? Let's kind of get rolling with one that looks particularly worth our time. Noah. Second one, bottom. I'm glad you picked this one, Noah, because this one does have a greatest common factor, which kind of adds that extra step. So we have 30x squared plus 25x minus 20 equals 0. What can we take out of each term here? This time we do have to do that step 1. Factor out that GCF. Yeah. Take out a 5. Okay? That goes outside of parentheses. And if you take a 5 out of 30x squared, you're left with 6x squared. Take a 5 out of 25x, you're left with 5x. Take a 5 out of negative 20, you're left with negative 4. Okay? And again, if you this is nothing new that we're covering here. This is all from PO52. Okay? That 7-step process that is in your binder. It's all printed out for you. We followed it. Okay, you can check there. Step 2, we're multiplying A and C together. And our A and C terms are now 6 and negative 4. Since we factored out that 5, we can ignore this original equation. Okay, we're now focusing on what's in the parentheses for A, B, and C. So we're multiplying 6 and negative 4 together, which equals negative 24. So step 3 now, we're looking for 2 numbers that multiply to make negative 24. And those same numbers add to equal positive 5, our B term. What's the magic combination here? Multiply to make negative 24. So one's got to be negative to get that negative product. Yeah. Negative 3 and 8. Yes. Negative 3 times 8, negative 24. Negative 3 plus 8, positive 5. Now we can start to set it up, and this is probably where we're going to have to stop. But since this one did have a GCF, that goes out in front. And then in our parentheses, each of them get a 6x again, because that's our new A term now, after we took out that 5. And then 1 gets a negative 3, and 1 gets a positive 8. The numbers that we came up with in step 3. Now you would simplify each set of parentheses like we did in the previous example. Your last step would be to distribute that 5 back into only the first set, right? Okay. Of the 6 that I highlighted here, do 3 of them. That way, if there are mistakes made, you still have 3 more to practice on. So homework for tomorrow. 3 of the 6. This could be one of the 3 if you finish it out. But just 3 of the 6 for homework. Any question for you? Okay. All right, folks, you may go. Have a nice day.